Good afternoon, everybody. Today we're going to spend some time talking about why zero factorial equals one. Now let's start with a little background here. What do we mean by this factorial operation? Common letter in math is n. Let me where I'm at here, folks. Okay, I'm trying to learn how to use this Blackboard here in Zoom. But anyway, let's back to it here. Now, y'all, factorial has a specific meaning. Y'all, I'm trying to write a lowercase n here. And y'all, this exclamation mark doesn't mean n. It means this. It means you start at the first natural number 1 and you keep multiplying. Okay, and I'm going to put the ellipsis here. We can't go on forever. Times n minus 1 times n. So again, this is just a mathematical notation stating that you start at 1 and you multiply all the natural numbers all the way out to n. For example, 4 factorial. 4 factorial, y'all, in that exclamation, I guess it just means all the natural number factors. So you can write this as 1 times 2 times 3 times 4. Now this ends up being 24. Okay. All right, so that's what we mean by factorial. Now, what we're trying to establish today is why would 0 factorial equal to 1? Okay, we're going to actually try to show that that's consistent with this definition. Now, let's rewrite n factorial in a way that might help us to see this. Here's n factorial. Now, based on this prior definition, you can rewrite this is n times n minus 1 factorial. And you see, that's just something that follows immediately from the definition. Okay. Okay, folks. Now, again, if n factorial means this, it means 1, 2, 3, all the way out to n. N factorial would be n, and then times n minus 1 quantity factorial. Okay. Now, play with that if you don't believe that, but that has to be true. That has to be true. So now, the way we can see that 0 factorial has to equal to 1 is just choose n equal to 1. N equals 1. Okay. So that means if you place a 1 right here, you get a 1 factorial, okay, which is just kind of by default 1, right? And it follows from the definition, just 1 times itself is 1. Okay, so now right here, substitute 1 right here, you get 1. Then here's where we get our magic. We get 1 minus 1 factorial. Okay, but this all just creeps out into 1. Let me just carry on here, folks. You get 1 factorial is equal to 1. So you can say 1 is equal to 1 minus 1 is 0. Last time I checked. Okay. There you go, folks. Voila. So we can write down QED here. Thus, we've demonstrated. That's the way a lot of math people like to end proof. Now, this wasn't much of a proof, but it's a proof nonetheless. Okay, so QED. So that's kind of strange. It's kind of strange. Is that you would think 0 factorial might be 0 if there's any justice in the world. Now, let me show you why this is actually kind of important to have that as a convention. There's what they call a combination formula, and I'm going to write this down for you. You may have heard of combinations, and what it is really an unordered selection. So let's use this notation. It's pretty common in math. This reads N choose R, folks. And it actually has a very precise meaning. It means, like, for example, let's say you had a bag of 5 marbles and you wanted to know how many ways you could take 2 of those marbles out. That would be N choose R. Now, let me just write this down so we'll get past some of the talking here. this has a definition. It's n factorial over n minus, let me erase this, folks. I'm running out of room here. Excuse me just a minute. End up writing sideways unintentionally. Okay, so back to it. This is the definition of something that's kind of interesting. Actually, it gets used actually when they calculate the lottery odds. So this is n factorial over. Now the formula looks kind of ugly, but it's actually quite easy to work with. N minus r, and r is the size of your selection. Okay. Now, so we have r factorial here, and then r factor. I'm limited by the size of this crap. Let me do this over. Sorry. The technology just isn't quite there. This thing doesn't scroll like it should if it was worth its salt. So I will vent there. Now let's try one more time. Okay. Right here, folks, this means n factorial divided by again, I'm battling this thing. It's not the best, but I shan't complain any further. Okay, go. There we go, folks, finally here. Now, again, this formula looks a little more unmanageable than it really is. That reads n minus r quantity factorial. Okay, like that. And then right out here, we put r factorial. R factorial. Okay. Now, this literally means the example I used a moment ago. Let's say you have a bag of 5 marbles. All right, you want to know how many ways can you pull 2 marbles out of that bag? So let's go ahead and let's write this down, and you're going to see why it's important. Hope it's worth the wait. That 0 factorial is equal to 1. Okay, so we have n equals 5 and r equals 2. Bag of 5 marbles. We want to know how many ways are there to take out 2 marbles. So I'm going to come back over here and finish this, folks. Just because I'm running out of room here, this isn't quite the way I want it. So what you would have here, folks, would be 5 factorial over, now, y'all right here, 5 minus 2 is 3. So this would be 3 factorial. Again, y'all, all I did was place the 5 right here and the 2 right there, right? The factorial operator remains. And then r is 2, so we have 2 factorial. Now, a little bit of an exercise here. And I'll just say it rather than write it, because I'm a little limited right here. This means 1, 2, 3, 4, 5, right? This means 1, 2, 3. So the 1, 2, 3 from here is going to cancel with the 1, 2, 3 that would be right here. And so you would have 5, that's a 5, not an S, times 4, over 2 factorial, which happens to just be 2 because 1 times 2, right? It's the only factorial that's that way. 1 times 2 is 2, so you still have a 2 right here. And this is 10. So folks, again, there would be 10 ways. 10 ways. God, I told you I wouldn't complain, but I'm running out of room here. Yo, there's 10 ways to actually take 2 marbles out of a bag of 10, out of a bag of 5. Now you can do that yourself if you got the time. During the coronavirus, we all have time to check these things, right? So take a bag of 5 marbles, count the number of ways you can take 2 marbles out. It's good to have 5 distinct marbles, different colors there. There's actually 10 ways that can be done. Okay. Now let's take a look at the circumstance that's kind of absurd here. How many ways are there to take 5 marbles out of a bag of 5 marbles? Well, we don't need a math whiz to tell us that that is equal to 1, right? This notation is kind of absurd, but just by intuition, that better be equal to 1, right? I'm either retarded or this technology just isn't quite right. Probably a little bit of both. Okay, so let's put 1 right there. Okay. Now, so how does this tie into 0 factorial equals 1? Well, if you take a look, if you put a 5 right here, you would actually have 0 factorial. Okay. Again, if you put 5 would go right here where you have 5 factorial right here, but then you would have 5 minus 5 here, which would be 0 factorial. So you see, if 0 factorial was not equal to 1, this formula right here would break. Okay. The 0 factorial is absolutely crucial, or this formula right here would break. I'll write it right underneath so you guys can see what I'm talking about right here. You would have 5 factorial. I'm just making sure you see that the formula corresponds to what you know has to be true. Okay. 0 factorial right there. And now if that was 0, we would have a problem because everybody's learned that you can't divide by 0, right? Dividing by 0 is what they call an undefined operation in mathematics. But yeah, you see there, this is equal to 1, so the formula does produce what our intuition expected. Yeah, I'm sorry that drug out, but to me, it's good to know why these crazy rules are true. If 0 factorial was not equal to 1, this is what they call a combination formula. There's also a permutation formula. All of those formulas wouldn't work, and also some of the results from statistics would break. When you're doing like the binomial distribution, for example, you need for 0 factorial to equal 1, even though it might not intuitively feel that way. Okay, y'all, thanks for your patience. Till next time.